Welcome back, guys. Patrick here. Moving on to the next question. We have to take this whole expression here and we have to simplify it. So what we're going to have to do is we're going to have to expand all these brackets, collect all the like terms, and then simplify it. So what I'm going to do, I'm going to start with this side over here. Now, if you notice this x squared minus 3, x squared plus 3, notice that that's a factored difference of squares. And so we don't necessarily have to FOIL everything out and simplify it. You can do that if you want. If you want to go through all the steps, you could recognize here that this is a difference of squares. So you can actually, if you want, just multiply the ends of these two brackets. So x squared times x squared gives us x to the 4, and then negative 3 times positive 3 gives us minus 9. Right? So when you FOIL these two brackets out, this is what you would get after simplifying. Then we got the 3x plus 9. So it saves you all that work in the middle. These brackets aren't always going to be the same. Then you would have to FOIL it, but in this case, these two will simplify to this. And then over here, what I'm going to do, notice that this is just one term. I'm going to actually bring it in front because then it's in a format that's a little nicer, we're a little more used to. You don't necessarily have to. I'm just going to, because then it's a little obvious to see, or a little more obvious to see, that we could distribute the negative 3x to the 3. Versus here, if we distribute it in the bracket, we may forget about this negative 1 in front, and then things can get a little messy. So I'm just going to bring this in front. And then from here, I'm just going to expand everything. So x to the 4 times 3x. Be careful with your algebra. 9 times x to the 4 gives us positive 9x to the 4. This times that gives us minus 27x. And then this times that gives us minus 81. And then we got minus 3x to the 5. This times that gives us minus 21x to the 4. And then that times that gives us positive 15x to the 3. Like that. So we just expanded everything, and now we could collect like terms. So notice that, what are we going to have here? Notice actually that the 3x to the 5 minus 3x to the 5, those cancel out. So those are gone. They net out to 0, and there's no other x to the 5s. We got 9x to the 4 minus 21x to the 4, which would give us 9 minus 21 gives us negative 12 x to the 4. Then we got this x to the cubed, right? That's the next degree, and there's no other x to the 3s. So that's gone. And then minus 27x minus 81. No other like terms. All right, so there's actually not too many like terms besides the x to the 4. These two and then these two cancel out. So you can't simplify this any further. That's the final answer. This can be in a potentially different format as well. If it's a multiple choice question, you can actually take out a negative 3 from all these, or even a positive 3, but because the leading coefficient here is negative, I'll take out a negative 3. And this would end up being, if we take a negative 3 from here, that would be positive 4 x to the 4. Notice we can't take out any x's because of this constant at the end here. 15 divided by negative 3 gives us negative 5. Negative 27 divided by negative 3 gives us positive 9. And then negative 81 divided by 3, that would give us positive 27. Like that. Right, so this here is another format that this could be in. Right, but usually the final answers in most textbooks is going to be the expanded form. So either one of these works, they're both the same thing. Those are the simplified formats of that expression.